Ukrainian firm builds heavy electric UGV with 100 kilometers range. A Ukrainian company has built a heavy electric robotic ground vehicle designed for the kind of terrain and threat environment that the war in Ukraine has made grimly familiar, and the Mamont prototype addresses the battlefield realities that off-the-shelf systems were never designed to handle. Armolab, a Ukrainian developer, has unveiled the Mamont Ukrainian for Mammoth as a prototype, heavy electric uncrewed ground vehicle configured around a 6x6 all-wheel drive chassis. With high ground clearance, the combination of 6 driven wheels and elevated clearance gives the platform the ability to operate across the difficult terrain conditions that define much of the Ukrainian front river crossings, mud and marshy ground that stops lighter or two-wheel drive platforms before they reach their objective in a war where logistics and resupply at the tactical edge has become one of the most dangerous missions. A soldier can perform. A robotic platform that can physically go where the resupply needs to happen carries immediate operational relevance. The powertrain architecture reflects deliberate engineering choices shaped by combat experience. Armolab equipped the Mamont with a liquid-cooled electric drive system designed to operate in sustained normal mode even across sections of difficult terrain, a specific design decision aimed at eliminating powertrain failure as a cause of mission abort in precisely the conditions where the vehicle will be used most heavily. Electric drives in military ground vehicles can face thermal management challenges under sustained high-load conditions. The liquid cooling system addresses that vulnerability, directly keeping the powertrain within operating parameters when the vehicle is working hardest. The battery system provides 100 kilometers of autonomous range, a figure that positions the Mamont as a platform capable of meaningful tactical reach rather than a short-range demonstration vehicle for a robotic ground system operating in a resupply or engineering role at the tactical edge. 100 kilometers covers a substantial operating area, particularly when the vehicle can be operated remotely and returned to a reload or recharge point without crew exposure in the forward area. Payload capacity is 700 kilograms with remote unloading capability and a maximum speed of 40 kilometers per hour. The remote unloading function is operationally significant. It means the vehicle can deliver its cargo without requiring a crew member to dismount and physically unload in a potentially contested area. The speed figure places the Mamont in a range where it can keep pace with, or at least not significantly delay, the tactical movements it is designed to support. The passive protection approach Armolab has taken is worth examining in detail because it reflects hard-won Ukrainian experience with FPV drone threats rather than adding reactive armor or active protection systems. Approaches that add weight, complexity, and cost. The Mamont's protection against FPV drone strikes comes from the structural geometry of its dump truck-style body frame and the design of its hood. The safety cage structure of the dump body provides passive protection from above, while the hood's form factor and construction shield the powertrain and electronics from strike damage. This approach acknowledges a reality that Ukrainian operators have learned through experience. A vehicle that survives an FPV hit because its critical systems are structurally protected is more operationally useful than one that is destroyed because its vulnerable components were exposed. The modularity system Armolab built into the Mamont is the feature that gives the platform its long-term operational flexibility. A universal rapid mount and dismount system allows engineering or combat equipment modules to be swapped without tools. No spanners, no specialized equipment, no maintenance personnel required, just the module change itself. That capability means the same vehicle can be configured for logistics, resupply on one mission, and carry a different payload, engineering equipment, a weapons station, electronic warfare assets, or sensor packages on the next without returning to a depot or waiting for technical support in a resource-constrained operational environment where the same piece of equipment has to serve multiple functions. Tool-free modularity is not a convenience, it is a force multiplier. The platform's dump truck body configuration, the basis of the passive FPV protection through its safety cage frame, also serves the primary logistics mission directly. A vehicle that can carry 700 kilograms of ammunition, food, water, or medical supplies to a forward position, dump the load remotely, and return without putting a driver at risk addresses one of the most dangerous and resource-intensive tasks in contemporary Ukrainian ground operations. Resupply under fire has cost Ukrainian forces significant casualties across the war's duration, and the tactical logic of replacing human crewed resupply runs with a robotic system in high-threat areas is straightforward. Armolab has not disclosed production timelines, pricing, or procurement quantities, and the vehicle's combat utility will ultimately be proven in operational use rather than on a test range. But the design decisions embedded in the prototype liquid-cooled electric drive 6x6 all-terrain mobility, passive FPV protection through structural geometry, tool-free modularity, remote unloading reflect a development team that has been paying close attention to what actually happens to vehicles in the environment. The Mamont is designed to operate in